Leetcode practice question. In this video, there are two goals. The first goal is to find a solution for this specific question, and then we are going to do some coding work. And the second goal is to see how to solve this problem in a real interview. So let's get started. So in the real interview, the first step is always try to understand the problem. If there is anything unclear, please bring up the question and at the same time think about some edge cases. So let's see. Partition labels. So string S of lower English letters is given. So we want to partition this string into as many parts as possible so that each letter appears in at most one part. And return a list of the integers representing the size of each parts. Okay, so given this input string, we have output as 9, 7, and 8. Because for the first part, it only contains ABC, second part, the D, F, G, third part contains the rest of the letters. Alright, so I think I mostly understand the question. Let's see the constraints. So the input string is for sure going to be not empty, and also it is only going to consist of lowercase alphabets. Okay, so I don't think I can find any special edge case at this moment, so let's go to the next step. So in the next step, it's about finding a solution. So in this part, you communicate with your interviewer about the idea how to solve this problem, and also do some necessary runtime space analysis. And after you get an agreement, that's the next part, which is doing some coding. So let's see how to solve this problem. So I think the first idea that comes to my mind is we record the last appearance of each character. So for example, we have the last appearance of A, B, C, D, E, F, G, something like that. And then we do another one pass for the string. So we will keep a variable to record the last index, the current last maximum index. So let's say we have the current maximum index, last index for A, and then because the last appearance for B is smaller than the last appearance of A, so we are not going to update the max index. And similarly, C is not larger than last appearance of C comes before last appearance of A, so we are not going to update the maximum index. And then when we hit the maximum index, which is the last A, then we are going to restart and also keep record that we already have one segment. So in this way, the runtime is going to be all of them because we are doing two passes through the string. And I think this should be the best one regarding the runtime. So having said that, let's do some coding work. So for coding, we care about the correctness of the code, the readability of the code, and also don't be too slow in the coding part. So let's see. First of all, we need to record the last index for each character. So this is the integer. Let's call it car last IDX. So we are going to go through everything, every character within the string. So it would be car last IDX output s.car at I and I. So after that, we need to do another pass. So we would say I is equal to 0, I smaller than s.length plus I. First of all, we will need to initialize a last index. Let's say the last index. We will have this to be initialized as the last index of the first character in the string. So it is s.car at 0. So it will be something like if I is equal to the last idx, then we are going to push it. Okay, so we also need to define the result. So the result, it would be, so what should we return? So it should return, it seems like we return the list of the integers representing the size of each part. Okay, so it's essentially the size of each parts. So let's actually record the last index of each part, if possible. So do we really need that? Because okay, so maybe let's first record the last index of each parts. So its last index of each part is new linked list. Yeah. If I is equal to the last index, then we will have okay, so this is last index list. So last index list dot add the last index, and then if it's not equal to the last index, then we will see last idx is equal to this would be something like max last index, and this would be car last index dot get s dot car at I. So we are going to update the last index if we have a character that is outside of the previous last index. So then that should be pretty much it. And finally, we need to compute because we are just recording the last index instead of recording the length of each part. So we are going to change it a little bit. So let's say we are going to segment length new linked list. So we are going to say segment length dot add so because it is an index of, so if it is an index of it, then it would be something like first one, it would be last idx list I'll get 0 plus 1. Yep. And int I is equal to 0. Okay, so if linked list, then because it's linked list, so maybe we need to have this as array list, so for better performance. So if I is equal to 0, I is smaller than last idx list dot length or size plus I. So this I should be starting from 1 here. So the segment length dot add last index list dot get I minus last idx list dot get I minus 1. And finally, we return segment length. So after we're done with coding, it's time for us to do some testing. Let's see. So for testing, we need to go through a test case, do some sanity check about the logic, and at the same time explain how this piece of code is gonna work. So let's go through this piece of sample. Let's go through this piece of example. So let's say we have the input case as this. First of all, I think it's just too long. Let's make it a bit shorter. So let's say we have ABA, ABCA, and the DF, something like this. Let's say we have this. Then the last index, car loss index, it would be something like, let me see, is it 1, 2, 3, 4, 5, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8. There's 7, so last index of A is 3. Last index of B is 1. Last index of C is 2. D is 4. E as 7. And F as 6. So after that, we will have the last index list. And we will go through the string. So if first of all initialize last index as equal to 3, and we see that for B the last index is 1, which is not larger than 3. C as well, it's equal to 2. So when the index is equal to 3, when I is equal to 3, then it's time for us to update the last index list. So we are going to add the 3 into it. And then for the next thing, we are going to have last index as 4, which is here. Sorry, last index as, yeah, this is last index as 4. Yep, this is last index as 4. And then we are going to have the last index as 4. Okay. So I'm thinking, because the last index was 3, and then if I is equal to the last index, then I will have last index dot add a last index. Then we update it. But the thing is, if we are here, the last index was 3. So it's not actually up to date. So instead we should put this sentence before the if branch. So if we put this before the if branch, then I think we should be okay. Like for this one, first we update the max last index as 4, and then we see that I is equal to 4, and then we are going to put the 4. For the next part, we are going to update the last index as 7, and then when I comes to the 7, then we are going to add a 7 into it. So that should be able to solve it. And finally, first of all, we're having the segment length as 4, and then a 1, then a 3. So I think it should generally work based on this example. Let's see. Let's give it a shot by running through this. Okay, so it is, okay, it's S, which is capital S. Alright, so a lot of capital S here. Okay, so line 37, which is capital S. Yes, car. Line 42, which is car lost IDX dot get. So it's still, yeah, quite some typos to fix. Okay, so after fixing the typos, I think it looks good. Alright, so that's it for this coding question. If you have any question about the puzzle or about the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.